how to rationalise surds. So first of all, what do we mean by rationalising? Okay, so rationalising in this circumstance means not having a square root anywhere on the bottom of our fraction. Okay, we can have them on the top, but we just mustn't have any on the bottom when we finish. So how are we going to achieve that? So we know the basic rules with fraction. What we do to the bottom, we must do to the top. So we've got to figure out what we need to do to the bottom so that it's no longer a square root, no longer a surd. And the most straightforward thing we can do is to multiply it by itself. Remember that rule. So if you multiply a surd by itself like this, then it just becomes what's inside. So root 2 times root 2 is just 2. Now if I do that to the bottom, I must also do it to the top. And so 1 times root 2 is root 2. So this is our rationalised version of what we started with. So notice we haven't got rid of the square root altogether, but it's not on the bottom anymore. That is the objective. So let's do a couple more examples with a little bit more work to do here. So here we can see on the bottom we've got root 5. So to get rid of that, we're going to multiply by root 5 on the bottom. So the bottom of this one is going to just become 5. Now what we need to do is we also need to multiply the top by root 5. Now I've deliberately put that in brackets just to help out there. So it's just like you would do with expanding brackets. So 2 times root 5 is going to give us 2 root 5. And then root 5 times root 5 is going to give us 5. And so this is our rationalised version. 2 root 5 plus 5 over 5. Remember that. It's all about not having it on the bottom, not about the top. We'll do one more here. So we've got root 2 here on the bottom. So we know that we're going to multiply by another root 2 to get rid of that square root on the bottom. And what we do to the bottom, we must do to the top. So again, just think of that as one thing in a bracket. So we've got 1 times root 2, and then we've got minus 3 times root 2. So I'm going to write that as it is for the minute. So that's going to be minus root 3 times root 2. So this is where we need to use our rules to do with surds to simplify that, which in this case actually means going up and having just one root there. Okay, so root 3 times root 2 is actually the same as the square root of 3 times 2, which is root 6. So our final answer here is root 2 minus root 6 all divided by 2. Okay, so that's how we do rationalising of surds when we've just got a simple root on the bottom. Sometimes you could have a number in front of that, multiplying in that. You'd use the same tactic. So if I'd had 2 root 2, I would still multiply root by root 2. But my answer would have been 2 times 2, 4 on the end there. So we're now going to look at a slightly more complex version. So here we can see we've got some square roots, some surds on the bottom of these, but they are added to ordinary numbers or taken away from another surd in this case. Okay. So the problem is we can't use the same strategy we've just used, because if I was to multiply the bottom of this by root 2, it would turn that one into 2, but it would turn that one into root 2. So I'd still have a square root on the bottom, which is not what we want. Okay, so the secret to doing these ones is that special case that I've mentioned in a previous video, the difference of two squares. So I'm going to start drawing brackets in because it makes life a bit easier. So we're going to multiply this by its difference of two squares partner, which looks exactly identical apart from the fact that it's a minus on the bottom. And obviously what we do on the bottom, we're going to have to do on the top as well. Okay, so if necessary, you can multiply the bottom out so that you understand what you're going to get. But it is really, really useful to be able to understand that when you do a difference of two squares, what you're going to get is the square of the first, which is 1, minus the square of the second. So the square of root 2 is 2. So on the bottom here, we're going to have 1 minus 2, which is the same as minus 1. Okay, so that's taken care of the bottom. I'm going to use the space here to do some of the workings out for the top here. So we've got to do this multiplying out. So it's 4 times 1. Whoops, sorry. 4 times minus root 2, so that's minus 4 root 2, minus root 2 times 1, so that's minus root 2, and then minus root 2 minus times minus root 2, so that's going to be plus 2. So let's tidy that up a little bit here. So we've got a 4 plus a 2 there, so we've got 6, and here we've got minus 4 minus 1, so we've got minus 5 root 2. And so all of that, if you like, is going to sit over the top of our minus 1 that we worked out on the bottom. Now that looks a bit strange just to leave it like that, because if it was a 1, we wouldn't bother to keep it at all. So the only thing that's going to be different is just think. So 6 divided by minus 1 is actually going to be minus 6. And minus 5 root 2 divided by minus 1 is going to be plus. So you can see it's just changed the signs round. So this is our final answer. There's nothing on the bottom, okay, because we've taken care of that minus 1. So let's do another example. So we've got 1 plus root 3 on the bottom. So its partner is 1 minus root 3. And what we do to the bottom, we have to do to the top. So the bottom of this one is going to be 1 squared minus root 3 squared, which is 3. So 1 minus 3 is going to give us minus 2 on our bottom there. Okay, so let's multiply out the top. So we've got 5 times 1, 5 times minus root 3, so that's minus 5 root 3. Then we've got root 7 times 1, so that's plus root 7. Just like with algebra, we don't write 1s in front. So then we've got root 7 times minus root 3. So that's going to be minus altogether. And remember the rules. So root 7 times root 3 is the same as the square root of 7 times 3, which is 21. Now, if we look at this, there is nothing that is the same. No one part there is the same. So there's nothing we can do to simplify that at all. Okay, so the only thing I might do here is, because that's a minus 2 on the bottom, and I prefer not to have a minus 2 on the bottom, we might change all the signs on the top and have it over a plus 2. So that would, sorry, that would mean we would end up with an answer that looks like this. So I haven't left myself enough space here, have I? Okay, so I'll write small. it would be minus 5 plus 5 root 3 minus root 7 plus root 21, and all of that would be over 2. Okay, we'll do one more example here. So here we've got roots both sides. It's not a problem. Just remember that we're going to multiply by the, in this case, the positive version. So it's always just the pair. So difference of two squares, they're identical apart from the signs. So I'm going to do the same on the top. And I'm probably going to run out of room, so in a minute I will need to go and grab another piece of paper. But let's keep going here. So what are we going to have on the bottom? We're going to have the square of root 3, which is 3, minus the square of root 5, which is 5. So that's 3 minus 5, so we're going to get minus 2 on the bottom there. Okay, so on the top we've got minus 2 times root 3. So that's minus 2 root 3. Then we've got minus 2 times root 5. So that's minus 2 root 5. Then we've got root 5 times root 3. So remembering the rule, that means we've actually got the square root of 5 times 3, which is 15. And then finally, we've got square root of 5 times the square root of 5. So that actually gives us just 5 on the end there. Okay, again, if you look at this, you can see there's no parts of that we can actually combine. And again, we've got that minus 2 situation on the bottom, and so that it looks nicer and we just have 2 on the bottom, again, we're just going to change all the signs here. So we'll have 2 root 3 plus 2 root 5 minus root 15 minus 5. Sorry, I tried to squeeze that in so I didn't have to go and interrupt and get another sheet of paper. So, need to be confident with your difference of two squares and with multiplying out brackets to do these harder rationalizing ones. But if you are, then the rest of this is not hard at all.